Dear ladies and gentlemen, my name is Alexey Kondurin. I would like to present my talk about our future in space. Let's at first remember how did we get into space, I mean space flights. Our space flights were started almost 70 years ago from such small spaceship. Tiny one pilot cabin was turning around the Earth. It was perfect at that time. It was enough volume to survive in space for a few hours. Next milestone is the moon missions. Two astronauts occupied a cabin for a couple of weeks. The pressurized volume was about 6.7 cubic meters, just to land, walk on the moon and go back. Not much volume like a minivan car, but enough to survive. Then the space stations were built in low Earth orbits. The volume of the stations was increased from 70 cubic meters in first stations to 900 cubic meters in International Space Station. This volume is enough just to be in orbit up to 6 or 12 months. Not far from Earth. Simple tiny experiments. Permanent support, food, air, water from Earth. Excellent. Done. So, our presence in space is growing. The pressurized volume in our space constructions in Earth orbits follows the exponential law with time. Why? And what will be the next? Our technology to build space station is based on ready-to-use blocks prepared on Earth and sent one by powerful rockets. 20-ton payloads, 15 meters length and 5 meters diameter. These are limits. International Space Station was built 10 years, multiple launches, 150 billion cost, risky, expensive. Would you like to repeat again? What for? For tiny space experiments? New walk on moon? What can we do with our present technologies? Interplanet ship to Mars? No volume for food, water, crew. Not sufficient radiation protection. Moon base? Again, it will be tiny volume inside. Food and water support from Earth. Delivery is too expensive. Space factory. How can we make a profitable business in a garage-size volume? Can we have a green garden for food, water, and air regeneration? No, forget. Large scientific or industrial equipment in space? No. Massive radiation protection for deep space mission? No. We have nothing. To go further, we have principal limit, wall, barrier. We must break this barrier. We need very large space constructions with pressurized volume enough for large spaceships or space base or space station with large green garden for food, air, water, for space factory with large industrial size equipment. We need large volume for large crew, and so on. This is the next step. How can we get it in space? I propose a principally new way, making in space, building in space. As we do it on Earth, if we need big building, we build it in the right place. We do not move the building from the builder factory. We build it where we need it, where we use it. Let's do it in space too. We have designed and proved this concept in many years. Composite materials, what we use when we fly with airplane, prepared with uncured resin, is prepared on Earth, packed compactly into container, sent to orbit, unpack, unfold, and cure resin directly in free space environment. Finally, we will get large, strong construction in orbit or on Moon or Mars. When the construction can be pressurized with air, the crew can install all required equipment, systems, space garden, and so on. What construction can be built with such technology? For example, pressurized volume of 7,000 cubic meters after one launch, one rocket, with 20 tons of payload. Compare with total volume of International Space Station, just 900 cubic meters after 10 years of space launches. If we will use multiple launches, as it was done for ISS, International Space Station, we can build a space city. This is our goal. 1 million cubic meters constructions with space gardens, factories, permanent large crew, self-sufficient spaceship. It can fly to any planet or even beyond. But the problem is the curing process for composite materials in free space environment. We carried scientific investigation in this field for more than So I will tell the details of the project in my talk. Please welcome. Thank you.